Good morning. I think we are live. Good morning, everyone. Hope you are doing great. Welcome back again in the bridge course for our target of NEET 2026. Yeah, good morning. Right. So, till now in our journey so far, we have learned the fundamental techniques of mechanics, and every day we start with learning something new. But also every day I'm telling you in every session that whatever you are learning these days in this bridge course in a particular session, that is going to get repeated almost in every topic and every chapter of physics, which you are going to come across throughout your preparation. All right. So yes, these are the fundamental things which we are learning, but at the same time, these are the days when we have to make our discipline also follow the things very strictly. For example, two things I'm telling you these days. One is primarily the rule of revision. So whatever we are learning in the physics chemistry morning and physics chemistry evening session, I hope that you are revising that before you are sleeping every day. If not till now, then start revising. The rule of revision is whatever you learn from morning to evening, that you must be revising before you sleep. All right. So definitely you'll remember it for more number of days, and whatever doubts you have, you can be asking those things in subsequent session right now in the live chat section. And once you come to the academy, then definitely you can ask us. Okay. So keep collecting your doubts, keep asking your doubts, get it sorted. I hope that these sessions are going to are contributing in upscaling your knowledge, and definitely in a longer run these are going to benefit you a lot. All right. So before taking too much time today, yesterday we started our discussion with the topic of oblique projectile motion. Projectile means an object that has been thrown. All right. The term oblique means angular. So when you are throwing an object in making some angle with horizontal or vertical in a random direction, making some angle with horizontal or vertical. Generally, it is made with horizontal, but sometimes examiner in the question may also say that the angle is made with vertical. In all such conditions, when you ignore air resistance and you throw a ball, once thrown, it is moving in the air only under the influence of gravity. All right. So its motion will be oblique projectile motion. Oblique means angular, projectile, the thrown object, its motion we are going to study. So yesterday we already started with this discussion. Today I'll sum up this discussion along with a lot of problems, especially the NEET PYQ, so that we can understand what type of questions are actually coming in our target exam. All right. But before that, I'll also make you revise everything, whatever we have learned till yesterday, till today in the yesterday's session. Okay. So we started with the basic concepts. These are 4 different NCERT things related to the oblique projectile motion, which we have discussed yesterday. All right. So one by one, let me revise it for you. So just a moment. Right, I'm removing it from here so that one by one we can revise these things. All right. So what you can see right now in front of you, that's the oblique projectile motion. So what I have seen here is that there is an x-axis, there is a y-axis, this is the origin. Let us assume that we have thrown the ball from the origin. Okay, all these things we have already learned in our last session. Just quickly, I am revising it for you. One short recap, then we will proceed further. So if you throw an m-mass ball or m-mass object with a u velocity, this u is called velocity of projection. Theta is made with horizontal, so that is called the angle of projection. Angle of projection. Generally, angle of projection is made with horizontal. It's not necessarily made with horizontal. Generally, it is with horizontal, but sometimes in the questions, it may also happen that the angle is made with vertical. So what to do? What to change, sir? If angle is made with vertical instead of horizontal, then if angle is made with vertical, then you have to change every formula that contains sine. that sin theta must be replaced by cos theta, and in all the formula where cos theta appears, that cos theta must be replaced by sin theta. So I'll say the tip is, if angle is made with y axis, then sin theta must be replaced by cos theta must be replaced by sin theta, which means sin theta and cos theta will be interchanged. Okay. Now, if you see here, the initial velocity right now as per the diagram is making an angle theta with the horizontal. So horizontal, according to vector resolution, the x-axis will contain u cos theta component and the y-axis will contain u sin theta component. Okay. Now, if I try to mention the parameters in x-axis as well as in y-axis, so clearly observe that x-axis, your initial velocity is u cos theta plus positive, forward positive, backward negative, and in y-axis, upward positive and downward negative. Alright. So in x-axis, your initial velocity is u cos theta. In the forward direction means we can take it as positive. There is no air resistance, no other force, buoyancy, this, that, nothing is there. Only gravity is there, and gravity is acting down. If gravity is acting down, then in x-axis there is no acceleration. Means x component of velocity will never change because there is no acceleration in the x-axis, and such type of motion will be called as uniform motion. Whereas in y-axis, the initial velocity, what you can see, is u sin theta. The acceleration is due to gravity downwards, so that's why it is minus. As acceleration is considered to be constant here near the Earth's surface, gravity is considered to be constant. So in that case, the y-axis motion will be uniformly accelerated motion. X-axis motion will be uniform motion. Y-axis motion by nature will be uniformly accelerated motion. Alright, I think this much is clear. Now what is happening? When you throw a ball from origin, it spends some time in air. For some time it moves upward as well as forward, and later it moves forward as well as downward. So here upward and forward, here forward and downward. So when it is moving upward and forward, this time is called time of ascent, ascending time, ascent time, upward and forward. Then it is downward and forward. This time is called time of descent, falling time. Alright. The total time of ascent plus descent is called time of flight. Means the time for which the body is flying, the time for which the body is in the air, the time after which the body falls back on the ground, the time for which the body is flying, the time for which the body is in the air, or the time after which body lands back on the x-axis, that time is called time of flight. So what is the condition of time of flight? The condition of time of flight is that body must be landing back on x-axis. If the body is landing back on the x-axis, its y coordinate is going to be 0. So I'll consider the motion in y direction. Sy is equal to uy into t plus half ay into t square, which means I have applied second equation of motion, s equal to ud plus half ad square in y-axis. By doing that, what I got is the time formula is 2u sin theta by g. It's an NCERT formula. You are supposed to remember this. First NCERT thing is clear, and ignoring air friction, assuming that there is no air drag, out of this 2u sin theta by g, half will be the ascent and half will be the descent. Half will be the time of ascent and half will be the time of descent. Means u sin theta by g single time will be ascent and u sin theta by g single time will be descent. That we will see it in a while. Right? Next thing. Throughout its journey or throughout the time of flight, whatever displacement it covered in horizontal direction, that is called horizontal range. Throughout its journey, throughout the time of flight, whatever displacement it traveled in horizontal direction, that is called horizontal range. So, for horizontal range, which direction motion we have to consider? X-axis or y-axis? Tell me in the comment section. For time of flight, we have considered the y-direction motion. For horizontal range, we must be considering which direction motion? I hope you remember the logic that advantage of breaking the motion in a plane or any projectile motion in x-axis and y-axis is that we can understand these two motion independent to each other. We can analyze the x-axis motion ignoring the y-axis parameters, and we can analyze the y-axis motion neglecting the x-axis parameters. Yes, absolutely correct. So while considering the range, horizontal range, obviously we have to consider the horizontal motion or x-axis motion. To see, I'm going to write it here. Horizontal range, S equal to ut plus half at square, but applied in x-axis. So Sx equals to ux into t plus half ax into t square, where you can keep the ax value as 0. Alright, so what you got here as r is equal to u square sine 2 theta by g, u square sine 2 theta by g. Sine 2 theta can be replaced as 2 sine theta cos theta. 2 sine theta cos theta. Interesting part is, even if you make the angle with vertical, for a range, even if you make the angle with vertical, sine and cos will be interchanged, and hence this formula will not change. I repeat, when you make the angle with vertical, sine will change into cos and cos will change into sine. So in the time formula, where you write generally as 2u sine theta by g, if you make the angle with vertical, the same formula will become 2u cos theta by g. But in the range, when it is u square sine 2 theta by g, this formula will be unaffected. Don't make this mistake of writing sine 2 theta as cos 2 theta. No. Sine theta will be changed to cos theta will be changed to sine 2 theta will be remaining unchanged. I repeat, sine 2 theta will be remaining unchanged because of this formula where sine and cos will be interchanging. They will exchange their positions, and hence the expression will remain unaffected. I hope my point is clear. That's why I always prefer to teach oblique projectile motion into two phases, the way we are doing here. Phase 1 we already discussed it. Phase 2 we are re-emphasizing, so that you don't only memorize the NCERT formula, but you can feel it and you can consider all the modifications also. I hope you are liking it. Now, let's talk about the maximum height, this yellow color displacement. It is an x-axis or y-axis? Y-axis, which simply means maximum height, like as I said that for a while, the particle will be moving upward and forward. Then it will be moving downward and forward. So the maximum displacement covered throughout its journey, the maximum displacement covered in y direction, that is called Hmax. So previous to Hmax, the body's velocity component in y direction was up. That's why the body was moving upwards. Y component velocity here was upwards, positive. And in the descent, y component of velocity will be negative, naturally. So at Hmax, the body's y component of velocity will be 0. I repeat, the condition for maximum height is velocity is 0. But which velocity, sir? X-axis velocity or y-axis velocity? Naturally, it should be y-axis velocity component because it is attained in y. Alright. So see, Hmax, I derived it here yesterday. So maximum height is, I'm applying the condition since I have the information of v, that v must be 0 in y-axis, vy must be 0, and here uy and ay. Okay. So third equation of motion I'm going to use, v square is equal to u square plus 2as. As a result, the formula which you got is u square sine square theta by 2g. U square sine square theta by 2g. If you make the angle with vertical, again instead of sine square theta, it will have cos square theta. Okay. If you make the angle with vertical, then all sine will be changed into cos will be changed into sine 2 theta will remain unchanged because it contains both of them. Even after exchanging their position, it is not going to change. Alright. Now, sir, what is this design? This design can be a part of circle, can be a part of, ellipse, parabola, hyperbola, any or maybe any random curve also. How you are so sure, sir, that it is going to be a parabola? Not because of the design, dear, but because of the equation. Exact name of the curve must be given only if you are sure about its form, its mathematical equation form, right? For example, here I'm sure about its parabola only after I derive the equation of trajectory. Now, what is the equation of trajectory, sir? Equation of trajectory is that equation that relates the x-axis to the y-axis parameter. X-axis parameter to the y-axis parameter. by replacing time in between. So for equation of trajectory, what did I do previously? What did I do? I wrote the second equation of motion in x-axis. I wrote the second equation of motion in y-axis. Then I replaced t in the form of x so that I can get an equation. I can establish a relation between y and x. I can establish a relation between y and x, and the equation of trajectory which you get is y is equal to x tan theta minus gx square over 2u square cos square theta. If the angle is made with vertical, then all sine will be changed into cos, cos will be changed into sine. So instead of tan theta here, you will get cot theta, and instead of cos theta here, you will get cos square theta here, you will be getting sine square theta. All right. So make sure before you start the problem or the disk formula thing for projectile motion, you must be focusing on with which axis the angle is made. NCERT talks about angle made with horizontal, and the entire slide is dedicated to NCERT. All the four things are basically the inbox formula or NCERT formula. But the moment I'll make the angle with vertical, this step will be helpful in modifying these results. I hope that's clear. So this is what we have already learned previously in our last session. Any new student is there, then I would suggest you, any new learner is there, then I would suggest you to quickly take the screenshot of this. All right. I hope you're done. Yes. Any doubts to anyone on this slide? This was already previously covered, but I gave you a one-shot recap today. Any doubts, dear? Any doubts? You can put that doubt in the live chat session. I'll help you out. I just opened YouTube. This video is suggested for me. So maybe you are also a learner, dear. Okay. Any other doubts? Okay. Chalo. Now, second thing, I explained all NCERT part, but looking at the level of the NEET exam that came in 2025, I told you, you must be having a mathematical touch also and somewhat more modifications. The mixing of the concept and more modifications, you must be learning how to do that. So what I did is I took all the NCERT things and then I re-emphasized on them. For example, time of flight will be the sum of time of ascent and time of descent. It is 2u sine theta by g. Instead of remembering u sine theta when the angle is made with horizontal or u cos theta when the angle is made with vertical, better to remember it as 2uy by g, 2uy by g. Whatever it is, sine or cos, just remember it. We are in time of flight, we are interested in y component or vertical component of velocity. So more appropriately, for a 3D problem, I told you that you can write it as twice of u vertical by a vertical. Because if it is in x, y, z, all the axes, then you don't have to deal with ux or uy or uz. Nope. You have to deal with u horizontal and u vertical. U horizontal and u vertical. So time of flight formula is twice of u vertical by a vertical. Twice of u vertical by a vertical. A vertical will be naturally g here. Okay. Range will be equal to time of flight into horizontal component of velocity. So that is time of flight is already 2u vertical by a vertical. Multiply it with horizontal. I would say multiply this with u horizontal. Multiply it with u horizontal. You will be getting the range only. When you multiply the time of flight with the horizontal velocity, you get the range. All right. Similarly, h max. Similarly, maximum height depends on the vertical component. So that will be u vertical square by twice of a vertical. U vertical square by twice of a vertical. Another form of equation of trajectory, which one is more important, that is y is equal to x tan theta minus gx square over 2u square cos square theta. This format is the NCERT format. But what we are going to use majorly for our entrance level problems is that is x tan theta 1 minus x by r. X tan theta 1 minus x by r. All right. So I'm expecting you to remember this. Now what I did, I took one 3D based model of projectile. X-axis, y-axis both are forming the ground, means xy plane is basically your ground, and z-axis is serving as vertical. XY plane is serving as the ground and Z axis is serving as vertical. And the velocity in 3-dimension is given to you as this. The velocity in 3-dimension is given to you as 3i cap, 4j cap, 5k cap. This is given. No angle given. Entire vector is given and the diagram is given to you. So x-axis and y-axis, basically the xy plane will be serving as ground and z-axis is serving as vertical. So the resultant of x and y, the resultant of 3i cap plus 4j cap will together give you u horizontal and the z-axis component will be giving you u vertical, which means what you got here is, see, u horizontal is the resultant of these two and u vertical is alone this 5. Now if they are asking you the same thing in this 3-dimension, you can write it as t is equal to twice of u vertical by a vertical, where a vertical is g. So you just substitute it as 2 into u vertical 5 by 10, you got 1 second. Since air friction is ignored, half of this 1 second means 0.5 second will be ascent and 0.5 second will be descent. Once you got this time of flight, you are supposed to multiply it with u horizontal. Once you multiply it with u horizontal is resultant of these two, that is 5 into 1 second, you got range as 5 meter. And when you talk about the h max, that is u vertical square by twice of a vertical. U vertical is 5, that's 5 ka square, 25 by twice of 10. So 25 by 10, it's 25 by 2 is 12.5, by 10 you will get it as 1.25. I hope this problem is also clear to you. Let me know in the comment section. Is that clear? Any doubts? Show me a thumbs up if it is clear. Any doubts, you can post it over there. And for all the new learners, you can quickly take the screenshot also. All right. I hope we are done. Any doubts? No doubts. Very nice. That's why I'm taking this one-shot revision for you. Now, then 3 more things in front of you. First of all, condition for maximum range. Okay. Now these things are also used in javelin throw, shot put ball. You know, the mechanics is everywhere in our day-to-day life, right? Physics is everywhere in fact. So the concept is condition for maximum range. Now you have a ball in your hand. Assume there is no air friction, only gravity is there. And you're throwing it like this. When you have a ball and you're throwing it like this at a certain angle, and your intention is to throw the ball up to maximum range, then obviously you will be throwing the ball with your maximum capacity. So there is no question of the u value, because for maximum range, your capacity, your u has to be maximum. G is anyways fixed. So what you can control and regulate is, what you can choose is that at which angle I should throw the ball for maximum range, sir. At which angle the ball must be thrown. So for range to be maximum, mathematically we have seen that the sine 2 theta will be maximum. Sine theta or sine 2 theta or sine function will be maximum only if the input angle is 90 degrees. So if 2 theta is 90 degrees, theta will be 45 degrees. So what we got is the condition at which the range will be maximum. But how much will be that maximum range, sir? That maximum range is going to be u square by g, u square by g. See in this formula, u square sine 2 theta by g. If you put sine 2 theta as 1 or 2 theta as 90 degree, you will get the maximum range as u square by g. Interestingly, when you throw the ball at 45 degrees, when you have attained the maximum range, or during the journey or during the goal of attaining the maximum range, the maximum height will be attained exactly in the middle. And that maximum height which is attained exactly in the middle, that will be 1 by 4 of the maximum range. I repeat, that will be 1 by 4 of the maximum range. What I'm trying to tell here is, see, that if you're throwing it at 45 degrees, the R max which you are getting, here is 10 meters. So the maximum height will be attained at 5 meters. And the value of that maximum height attained is 2.5 meter. Once again, if you are attaining the maximum range of something, the maximum height will be attained at half of the range. And the maximum height attained value will be 1 by 4th of the maximum range. R max by 4. One more time I am repeating it for you. Listen to me very, very carefully. That is, whenever you are throwing the ball at 45 degrees, your range will be maximum. During the goal of attaining the maximum range, the maximum height is attained at half of the maximum range. And the value of that maximum height attained is 1/4 of the maximum range. Maximum range is 10. The height max attained at half of 10, that is 5 meter. And the value of that maximum height attained is 2.5 meter. Alright. So I think this story is clear. But sometimes examiner also twists the language of the problem. They say, if you have a maximum capacity of throwing a ball in horizontal direction as x, if you can maximum throw a ball horizontally up to a distance x, then what maximum distance the ball can be thrown up to if you throw the ball vertically? I repeat, when I said that this is R max by 4, 2.5 meters here, that is the situation when it is thrown at 45 degrees. But if examiner is asking you that your horizontal capacity of throwing is 10 meters, then what will be your vertical capacity of throwing? If the language is this, then in that case, you are not supposed to still throw it at 45, you are supposed to throw it vertically, like this. When it is thrown vertically, so maximum possible H max when it is thrown vertically, it is by the formula of U square by 2G. It's not the formula R max by 4, it is the formula U square by 2G. So that comes out as half of range, R max by 2. R max by 2. This is important. Okay. During the during the journey of attaining the maximum range, H max is R max by 4. But if you are about to check your capacity of throwing in the vertical direction, then it is R max by 2. R max by 2. Alright. So it is 5 meter if you throw it vertical. This 5 meter has nothing to do with this 5 meter. That is a separate story. That H max will be attained at half of the range. But here, if you throw it vertically, the value of H max attained is also half of the range. Tell me only this part. Is the fifth condition clear to you? Fifth condition, two different stories. What will keep happening at 45 degrees? And the second story, what will happen if you throw the ball vertically up? See that carefully and let me know in the comment section. Is that clear for you? Yeah, I understand that there can be confusion in the language. That's why yesterday also I attained it 2 times or 3 times. Today also I taught you and I repeated it, and today also I am repeating it twice or thrice, that several times you will understand the difference in the language. Then definitely you will be able to figure out the difference in the expressions. And as I say, every time in the physics exam, the drawback or the problem is not with physics or maths involved. Sometimes the problem is only because of the English, only because of the language of the problem. All right. So please focus on this. This is the H max attained when the ball is thrown vertically. This is the H max attained when the ball is thrown at 45 degrees. Okay. Clear? Now, let's go for the next one. That is Galileo's formula or complementary angle formula. I hope you remember that I started few days back this bridge course with Galileo's formula only. That is the ratio in odd numbers. That is the Galileo's contribution in motion in a straight line. So here, this is the Galileo's contribution in motion in a plane or projectile motion here. So what did he contribute, or what we understood by this formula? At 45 degrees, the range will be maximum, boss. At 45 degrees, the range will be maximum, but slightly greater than 45 degrees and slightly less than 45 degrees. Precisely speaking, at complementary angles, the range is going to be same. The range is going to be same, which means if you take an angle 45 plus alpha, or you take the angle 45 minus alpha, you can see these yellow colored trajectories. At 45 degrees, the pink colored trajectory shows the range is maximum. Slightly greater than and slightly less than, or more appropriately, 45 plus alpha and 45 minus alpha, or theta and 90 minus theta. For complementary angles, 30, 60, 45, 45, 37, 53, 15, 75. For complementary angles, we get the range to be equal. Okay. Ranges are equal, only ranges are equal. The trajectories are not identical. The one which is having greater H max will naturally have greater uy, greater component of velocity, as well as greater time. Means they will follow different trajectories, they will be having different times of flight. Means they will be landing back on the ground at different times. But the displacement covered in horizontal direction, the range they have covered, are going to be same. Okay, their ranges are going to be same. All right. So Galileo's formula is complementary angle formula. This was the sixth thing which we discussed. Seventh thing is relation between R and H max. For any general angle theta, tan theta will be equal to 4H max by R. One special condition is that you may have to tell, or you may have to remember the equation angle of projection if height and range are same. So tan theta is 4H max by R. If in a special case H max and R are identical, then in that case tan theta equals to 4, or the angle of projection with x-axis theta, that will be tan inverse 4. Okay? I hope that's clear. Let me know if you have any doubts. This is just the deduction. What I want you to remember is exactly this formula. Then the conclusion, complementary. Then this story, two stories hidden here, one complementary part here and one inboxed formula here. Okay? Let me know in the comment section whether it is clear, and for all the new learners, you can quickly take the screenshot. All right. Any doubts? Everything is clear? Okay. Let's go. Now, this was the last part which we discussed yesterday. Again, a quick recap I am giving, and then we'll start with further things. So, the 8th part is what I have taught yesterday, that acceleration as a function of time. Throughout its journey, the only acceleration body is feeling is gravity, gravity, and gravity, and that too along the downward direction, or you can say minus j cap. So, what you have got here is g in minus j cap, g in minus j cap. Velocity as a function of time, if you see, then that is final velocity in x-axis, final velocity in y-axis. Final velocity of x-axis never changes here. This Vx never changes because no one is there to change it. No acceleration is there in the x-axis. So Vx will be equal to ux only, that is u cos theta. But Vy will be changed because of gravity. Gravity will affect Vy. Okay, so first equation of motion uy plus ay into t, uy is u sin theta and ay is minus g. So u sin theta minus gt, that's what you got as a velocity vector here. Okay, u cos theta in I cap will remain the same, u sin theta minus gt, j cap. Fine. Now, let me take few cases of this, then we will talk about it further. So, if I am writing here, suppose for an example, if I am writing here for this one as example 1, if they are asking the velocity vector at t equals to 0, if they are asking the velocity vector at t equals to 0, so in this entire expression I'll keep velocity t as 0. If I keep this t 0, see, so this term will be gone. If this term will be gone, what you got is u cos theta I cap plus u sin theta j cap. So what you have got is u cos theta is available in I cap plus u sin theta is available in j cap. Similarly, example 2, if they are asking velocity at t equals to time of ascent. So I hope you remember what is time of ascent. Time of ascent is half of time of flight. Time of flight is 2u sin theta by g, and half of time of flight means u sin theta by g. So what you will be getting is u cos theta is in I cap plus u sin theta minus g into t, and that is in j cap. So if you look at it carefully, this t is basically time of ascent. This t is basically time of ascent here, and this time of ascent is u sin theta by g. U sin theta by g. Now look at that carefully. This g got cancelled. Then this u sin theta and u sin theta also got cancelled. Minus that is u sin theta minus u sin theta. That's 0, and hence what you got is only u cos theta I cap, which means at the ascent, at the time of ascent, this is the time of ascent somewhere here. At maximum height, the time after which you attain the maximum height is called time of ascent. Another definition of time of ascent. Okay. So, or the time during which you are going upwards. So at time of ascent, you see Vy component is 0 and Vx component is still maintained as u cos theta. U cos theta I cap plus you can write it as 0 j cap, 0 j cap. All right. Now, similarly, 10th part which we have discussed is that position vector. Assuming that you are throwing the particle from the origin at any time t, how do we write its position vector? So we will say displacement covered in x direction will decide its, the position vector component in x axis or I cap. So sx I cap plus sy j cap. So I would like to re-emphasize on this, that how do we get that? So what I'm writing here is, I'll apply the second equation of motion in both the axes. See, sx you can write it as ux into t plus half ax into t square. This much is an I cap plus similarly uy into t plus half ay into t square. This much is in j cap. Now see that carefully. That's what you got here. That's what you got. See, just substitute the values. What is the ux value? That is u cos theta. T as it is. Ax value here is going to be 0. There is no acceleration in the x-axis. So u cos theta into t, there is no acceleration there. Then it is u sin theta into t minus half gt square. I hope that's clear now. For all the new learners, you can quickly take the screenshot. Let me know any doubt if it is there. And one more thing here. One more thing. If you're telling here the angle at t equals to 0, I'll just write the time instants. This is t equals to 0. This is t equals to time of ascent, and this is t equals to time of flight. Time of flight, 2u sin theta by g. Now here, if the initial velocity vector, is making an angle theta, with the x-axis, here during the landing or after reaching back on the ground, here the final velocity vector will also make the same angle theta, but in different sense. Means initially, if it was moving anti-clockwise, if it was making an angle anti-clockwise with x-axis, finally it is making the angle clockwise with the x-axis. Is that clear? Initial angle is anti-clockwise, final angle is clockwise. Means if I have to talk about another thing here, that is 11th part, angular deviation produced. Angular deviation produced due to the presence of gravity. So I will say that, see, if I draw this as x-axis, your initial velocity vector is making this angle theta, and your final velocity vector is making this angle as theta. All right. So if I have to calculate the deviation, then if you haven't thrown the ball, like in the absence of the gravity, the ball would have gone like this. In the presence of the gravity, the ball is going like this, which means due to the presence of gravity, the ball has turned, the ball has deviated, and this angular deviation del is basically 2 theta. And according to the diagram, what is the sense? That is the clockwise sense. According to the diagram, it is a clockwise deviation, and the del is given by 2 theta, where theta is the angle of projection. I hope that's clear. Now you can take the screenshot. All right. I think we are done. Any doubts, dear? Nope. Let's go. Now we will talk about some more aspects of the same. Like, first of all, I would like to take you towards energy consideration for the projectile motion. So in this case, if you have x-axis, y-axis, origin, and you have got the m mass ball thrown with u velocity, standard case, making an angle theta with horizontal, it is going to be like this. Okay. At the topmost point, the Vy value will be equal to 0, and here the Vx value will be equal to the Ux value, and that will be equal to u cos theta. U cos theta. If at any point of time I want to write this kinetic energy at the top, then kinetic energy at the top will be half m v square. That can be written as half m under root of vx square plus vy square. Why you are writing it this way, sir? Because kinetic energy is a scalar quantity. Half mv square, v must be the speed or the magnitude of instantaneous velocity. At the topmost point, under root of, like, v will be given by every time under root of vx square plus vy square. At the topmost point, this vy will be 0. If this vy will and vx will be ux only, so it is half m ux square. So what you can write it as half m u square cos square theta. Half m u square cos square theta. 13th part, I want to write the potential energy at the top. Potential energy at the top, what it is. So wave 1, potential energy at the top plus kinetic energy at the top, conservation of energy here, that must be equal to potential energy at the bottom plus kinetic energy at the bottom. So let us assume that this ground, the reference level is x-axis. The reference level is the ground, x-axis, where potential energy is 0. Gravitational potential energy, GP, is 0. Suppose I'm just applying the conservation of energy here. So I will say the potential energy at the bottom is 0. The kinetic energy at the top, if you throw a ball vertically up, it goes and goes and goes, reaches at the top and stops. So when you throw a ball vertically up, it goes and stops. When you throw a ball at an angle, it stops only in vertical, but it keeps always moving in horizontal. So kinetic energy at the top is non-zero. In fact, what it is, that is in front of you. I'll just substitute everything here. So potential energy at the top will be equal to kinetic energy at the, I'll take this term here on this side, kinetic energy at the bottom minus kinetic energy at the top. Kinetic energy at the bottom speed is u. So it is half mu square, and at the top what you can get is half mu square cos square theta. So what you can take after taking half mu square common, what you can get is 1 minus cos square theta. Everyone knows 1 minus cos square theta is sin square theta. So it is half mu square sin square theta. That is the formula for potential energy at the top, half mu square sin square theta. Okay, this is one way of getting it. One way of getting it, which is, I will not say that this is the easiest or more suitable way. We have different methods also. We have different methods. For example, way 2, if I have to write anyways, potential energy at the top, then what is the general formula for gravitational potential energy? mgh. So that is mg h max at the top, then definitely this value is h max. So just put its formula. I hope you remember the NCRT formula. NCRT formula for maximum height is u square sine square theta by 2g. U square sine square theta by 2g. See, clearly this g and g got cancelled. The formula which you got here is potential energy at the top, that will be equal to half mu square sine square theta. Half mu square sine square theta. So if the examiner is asking you that, this is our way of doing it. Is that clear? That's our way of doing the same thing. Otherwise, it might go lengthy in the exam. All right. So this is the energy consideration. You can write, like, I have taken the energy at the top as well as at the bottom. If the examiner is asking you the same thing, kinetic energy or potential energy at any other point, then definitely what you need to understand is you can always apply conservation of energy. Is that clear? So we have talked about bottom, we have talked about top, but at any random point in its trajectory or in its journey, always the conservation of energy is applicable, neglecting air drag. So our assumption here was that we are neglecting air drag, air friction. Because if air friction will be there, then definitely heat dissipation will be there, and hence you can't conserve the mechanical energy of the system. Conservation of energy in that case cannot be applied. All right. So these are two more things which we have talked about. Quickly take the screenshot. All right. Now, some more concepts, or do you want to do some problems first? Let's do some problems. Then the remaining tips I will give you. Before starting the problem, let's take a quick recap for all the formula. Once again, a quick recap of all the projectile formula. Then we will see some numerical problems. Okay, a lot we have already discussed. A lot is still yet to be discussed. Every basic thing I'm going to cover here today. Okay, but before that, let me give you a quick recap of the formula and let us do some problems together, especially the NEET PYQs, to understand what type of questions actually come in the exam. So the four formula: time of flight 2u sin theta by g, or 2u vertical by a vertical. Under no air drag condition, you will say time of ascent and time of descent both will be half of it, means u sin theta by g, u sin theta by g. If the angle is made with vertical, that will be u cos theta by g, u cos theta by g. Range is always u square sin 2 theta by g. Even if the angle is made with vertical, there is no change in the expression of a range, because sin and cos will be still interchangeable within the sin 2 theta expression. Also, indirectly, you can say range is always calculated here by multiplying the time of flight with horizontal velocity. Multiplying the time of flight with horizontal velocity, Hmax formula u square sin square theta by 2g if the angle is made with vertical, u square cos square theta by 2g, or you can say u vertical square by a vertical, twice of a vertical. Equation of trajectory, you must be remembering the NCERT equation of trajectory, y equal to x tan theta minus gx square by 2, u square cos square theta, but a better format of equation of trajectory is, will come on the next slide, y equals to x tan theta 1 minus x by r. Alright, taking a recap of the formula before starting the numericals. So time of ascent, time of descent, half of it, half of the time of flight. Range will be, time of flight is whatever the time of flight you get, here it is twice of u vertical by a vertical, always multiplied with the horizontal component of velocity in order to get the range. Another form which I said about the equation of trajectory is y equal to x tan theta 1 minus x by r. 3D example we have already discussed few minutes back. Then condition for maximum range, theta is equal to 45 degrees. The maximum range value will be u square by g. The maximum height attained during the maximum range will be r max by 4. But you have to check, if you have to check your vertical capacity, it will be r max by 2. Alright. Galileo's formula or complementary angle formula, at theta and 90 minus theta, or at 45 and 45 minus alpha, 45 plus alpha and 45 minus alpha, precisely speaking, at complementary angles, the ranges are going to be same. At 45 degree, the range is going to be maximum. If we take the complementary angle, the ranges are going to be same, but the heights, time of flights, time of landing, everything is going to be different. The upper curve will naturally have higher Hmax. Higher Hmax will have higher Uy. Higher Uy will also imply that it will have higher time. Higher time means it will land later. And the lower yellow curve, it will land sooner. Then it is relation between general value of Hmax and r. Tan theta is equal to 4 Hmax by r. The special condition of getting the equal range and equal height, tan theta must be equal to 4. Next is writing the acceleration vector, velocity vector and position vector as a function of time, just by applying first equation of motion, second equation of motion, like that. Throughout the entire journey, the angular deviation produced, like in the absence of gravity, projectile or ball would have moved here. In the presence of gravity, it is moving here. So the total angle of turning or angular deviation produced is 2 theta, where theta is the angle of projection. Next is kinetic energy at the bottom, that is half mu square. Kinetic energy at the top is half mu square cos square theta. Kinetic energy is relatively easy to find out, but potential energy is also direct formula is mgh. So you can also apply the conservation of energy between any 2 points, neglecting the air drag, or you can use some basic direct formula of half mv square and mgh. Half mv square, v must be the speed, so it is always written as under root of vx square plus vy square. I hope that is clear. All right, let us start with few problems, then I will share few more concepts. Okay, are you ready to start with the PYQs, especially NEET PYQs? Then we will also elevate our level. We will see what are the JEE models, what are a bit more mathematical models. You know, the JEE mains questions are, actually a big pool of problems to be taken for the NEET exam. And the paper which we have got this time definitely establishes the fact that you must be having your level of preparation with JEE flavor also. Okay. So first of all, let us start understanding the NEET level problems. Then we will gradually we will elevate our understanding for the some more mathematically complicated problems also. But you know, our way will be always very different and very easy. Out of logic and formula, we always prefer the logic. So a particle moving in a circle of radius r with uniform speed. Uniform speed means you are talking about uniform circular motion. takes a time t to complete one revolution. So from the first line, what I can conclude is that this t will be equal to 2 pi r by v. 2 pi r by v. Okay. If this particle were projected with the same speed, the v is same, or velocity of projection, so let me write it as u. Okay. That is, this implies if I want to isolate u, that will be 2 pi r by t, because it is going to serve as the same speed is going to serve as the speed of projection. At an angle theta to the horizontal, theta is made with horizontal. If theta is made with horizontal, all NCERT formula are applicable. If theta is made with vertical, I will change the sign to cos and cos to sine in all the NCERT formula. Attained by the particle equals to 4r. This was the radius r. The maximum height attained is 4r. Maximum height attained is 4r. The angle of projection theta is. So second thing what I can understand here is that you are talking about angle of projection theta and h max. So h max formula, h max is given as 4r, or let me write the h max NCERT formula first. What is the h max NCERT formula? H max NCERT formula is u square sine square theta by 2g. U square sine square theta by 2g if the angle is made with horizontal, and it is made with horizontal in the question. So this h max value, they are giving it to be 4r. Maximum height attained is 4r. This u can be written as 2 pi r by t whole square. It is sine square theta by 2g. Sine square theta by 2g. If I just square it here, over here, I get 4r. It will be 4 pi square r square by t, and it is sine square theta by 2g. So what you can cancel over here, this 4 and 4 can be cancelled. This r and single power r can be cancelled. So what else did you get here? So 2gt will be multiplied here, 2gt, and that will be pi square r, and it is sine square theta, which means sine square theta will be equal to 2gt by pi square r, and hence theta will be equal to, first of all, I will take the root of it and then sine inverse. So sine inverse 2gt, pi is coming out, no, 2gt by pi square r and whole to the power half. 2gt by pi square r and whole to the power half. See, this pi square could be taken out of root also, which means pi can come out, but that will still stay inside the sine function. That's what I was checking in the option. So which option is correct now? Which option is correct? Theta is sine inverse 2g t square, 2g t, did I miss something? Yes, I missed this t square here. See, when we are squaring, I did the square only of the numerator. I missed this. This has to be the square of the denominator also. Then naturally, what we are getting is here 2g t square, 2g t square. I think fourth option is correct. 2g t square by pi square r. Sine inverse theta is equal to sine inverse 2g t square by pi square r. I hope that's clear. Option 4. Yes. Yes, Shakeen. Very nice. You found the error. Nice. Chalo. I hope this problem is clear for all of us. Okay. If you want, you can take the screenshot. At the end of the session, the notes will also be uploaded, and the in the description of the video, the notes link will be attached. Still, if you want for your revision, you can take the screenshot. All right, let's move on. A projectile is fired from the surface of the earth with a velocity of 5 meters per second and angle 8 degrees with the horizontal. The moment students see here that the angle is 8 degrees, they drop the pen there only. Now, sir, how do we know what is the value at 8 degrees? 8 degrees, it's a random degree, man. Either you can solve the value of sine 8 degree, cos 8 degree, tan 8 degree by trigonometric table, or by using scientific calculator, or the examiner must mention its value. No case is there. I mean, examiner is not mentioning the value, calculators and trigo table are not allowed. So majority of students have a tendency here to leave this problem only because of the involvement of 8 degree. Never do this in the exam. Never do this thing in exam. read the problem completely, and I consider the reading as complete reading only if you see the options also. Here it is not valid to see the option and do the option elimination, but you have to develop this habit. NEET exam, this national level exam, is an objective exam. So you have to read the entire problem and you have to dare to read the all options also. Sometimes or many times it will happen that you know how to solve the problems. But out of those many times, there will be few times when you can just see the options and you can say, oh, this is not possible, this is not possible, oh, this is the only option possible. You'll tick mark and move on. You also have knowledge, you also have practice, but there is no need to solve that problem by the conventional method in the exam. You can logically eliminate the remaining 3 options and you can directly focus on the 4th option that would be correct. Getting it? So try to understand that there are alternative methodologies which we are going to train you for, so that many questions in the exam you can directly answer orally. Okay? So although this is not one of those problems, but this is another type of limitation of the students, that they find it like 8 degrees how to calculate. That's why they leave this. But let's not do the mistake together. We will read this question, we will try to see how to do. So once again, I'm reading it for you. A projectile is fired from the surface of the earth with a velocity of 5 meters per second and angle 8 degrees with the horizontal. Another projectile is fired. So here we would like to break the question. Another projectile is fired from another planet with a velocity of 3 meters per second at the same angle. So see, angle is same. 8 degrees angle is same. So maybe when you divide, it will be cancelled, no? Follows a trajectory which is identical with the trajectory of the projectile fired from the earth. The value of the acceleration due to gravity on the planet is, for identical trajectories, I would say their ranges are also same. Trajectories, R1 is equal to R2 and H1 is also equal to H2. R1 is equal to R2 and H1 is also equal to H2. Let's talk about this. R1 is equal to R2. If I say R1 is equal to R2, which means U1 square sine 2 theta 1 by G1 will be equal to U2 square sine 2 theta 2 by G2. Okay. But here theta 1 is equal to theta 2. Theta 1 is equal to theta 2. So what you got is sine 2 theta 1, sine 2 theta 2 will be cancelled. U1 square by G1 will be equal to U2 square by G2. Just substitute the values. What they are asking is value of acceleration due to gravity on the planet, on the second planet basically. So U1 is from Earth's surface, you have thrown it with 5 meters per second. 5 square by G1 in the question is given Earth's surface 9.8. U2 is basically 3 meters per second. See this data, 5 meters per second from the Earth, 3 meters per second from another planet. Okay. So here it is 3 square by G2. So from here what you got is G2 will be equal to 9.8 into 3 square, that is 9, by 5 square, that is 25. So you see, if you have got 10 here, then 10 into 9 is 90, not even 100. And here it is not even 10, it is 9.8, so it is less than 90. If that would have been 100, suppose if the numerator is 100, then 100 by 25 is 4, right? But since it is less than 100, even less than, slightly less than 90, so you will say slightly less than 90 by 25 will be slightly less than 4. So slightly less than 4 out of the 4 options, if you see, the less than 4 data is only option A. Okay. Sir, what if we would have started from this? If we would have started from this, I would have written the formula for height, but exact story further must be same. Let us see how. So I would write it as U1 square sine square theta, formula will be changed, sine square theta 1 by 2g, that will G1 will be equal to U square sine square theta by 2g, this will be U2 theta 2 G2. Here again, rest of the story is same story, because 2 and 2 will get cancelled out, theta 1 theta 2 is same given for you, same angle, and hence the entire format will be same. So when they say identical trajectory, That means the ranges must be same, maximum heights attained must also be same. Although they may be attained, they can be attained at different time. Means time of flight, ascent, descent, time will be different, may be different, but ranges, heights and exact design of the path are going to be same. You can take a screenshot of this. Let me know if you have any doubts. In the chat section, you can let me know. I hope there are no doubts. Everything is clear for you. This was another NEET PYQ and a good problem. All right. Let's move on. Yes. The speed of the projectile at the maximum height. I hope you remember what is the speed of the projectile at maximum height. At maximum height, Vy will be 0. I would highlight it here. At maximum height, Vy will be 0. Uy will be Vx will be equal to Ux will be, and that will be equal to U cos theta. If they say speed V net, that is always under root of Vx square plus Vy square. So that will be, because this Vy is 0, so that will also be U cos theta. So they are talking about the speed of projectile at maximum height. We have talked about the vertical component of velocity at maximum height, horizontal component of velocity at maximum height, as well as the net speed at the maximum height. Net speed, that is U cos theta only. All right. The horizontal component never changes here. The angle of projection is, now what is given in the question? The given part in the question is that speed at the top, net speed at the top, that is half of the velocity during the projection. The speed of a projectile at its maximum height is half of its initial velocity or velocity of projection. This is basically U cos theta, that is equal to U by 2. U got cancelled. What you got is cos theta is 1 by 2. This implies theta is equal to 60 degrees or pi by 3. Theta is equal to 60 degrees or pi by 3. That's the result. Hence, which is the correct option here? The correct option is option A. All right. Now, the thing is that this question seems very easy. This question seems very easy. They ask the angle of projection. Angle of projection is generally made with horizontal. But if they mention that what will be the angle, this is theta is equal to 60 degrees with x-axis. If they ask the angle with y-axis, then definitely that will be complementary to it. If angle made with y-axis is required, then either you can start your process by changing this cos into sine. Then either you can start this process by changing the cos into sine. I'm telling you the same thing now, that sine will be replaced by cos and cos will be changing into sine. So if angle made with y-axis is required, then either you start the process by writing u sine theta as u by 2, sine theta is 1 by 2, so theta is equal to 30 degrees. Or else you can write this theta y as 90 minus theta x. As obviously theta x plus theta y will be 90 degree, right? Angle made with x-axis and angle made with y-axis, those are complementary to each other. So 90 degrees minus 60 degrees, and hence the answer is 30 degrees. If they ask that. If they just say angle of projection, then by default, for the sake of simplicity, you are supposed to make it with horizontal. I hope that's clear. Any other doubts? You're able to connect like whatever we have learned yesterday and today and whatever we are going to learn further. I hope you are able to connect and relate it with the problems. Few more. You can take the screenshot if you want. Right. Another one. This we have completed. Now, a projectile is fired at an angle of 45 degrees with the horizontal. Elevation angle of the projectile at the highest point as seen from the point of projection is. Elevation angle as seen from the point of projection. So before teaching you this, let me tell you one more concept here. Okay, without this concept also we can do this, but with this, just a moment, with this concept we will be able to do it a bit easier. So what I have seen, how many points we have done? 13. Okay, so this is the 14 pointer here, another property of a projectile. Now this is x-axis, y-axis, origin. From the origin you have thrown an object with u velocity making a certain angle theta. So let us assume that this is the trajectory. This is the trajectory, okay, downward parabolic trajectory here. Now at any point on this trajectory, if you consider at any point P, if you consider random point, okay, any random point P if you consider, then the angle of elevations with horizontal from the point of projection as well as the point of landing, if this angle is alpha and this angle is beta, if this angle is alpha and this angle is beta, then here tan alpha plus tan beta is always equal to tan theta, always. The proof I am not doing it right now. I just want you to remember this property. What is the property? Two friends are playing catch and catch. Two friends are playing catch and catch. I am throwing a ball. My friend is catching. Another friend is throwing. This friend is catching, right? The friend A is throwing. Friend B is catching. Friend B is throwing. Friend A is catching. Catch and catch. All right. So suppose I have thrown the ball and the ball is in the air. Now my line of sight, line joining the ball and my eye, line of sight makes an angle alpha with the horizontal, and at the same time the another friend is also looking at the ball, that where the ball has reached. His line of sight is making an angle beta with the horizontal. In that case, tan alpha plus tan beta is always going to be equal to tan theta. All right, tan alpha plus tan beta is always equal to tan theta. So let me come here now. Let us do this problem with property and without property. So first of all, common way of doing it. Common way of doing this problem. So a projectile is fired at an angle of 45 degrees with the horizontal. X-axis, y-axis, origin. What is so interesting regarding the 45 degrees part, sir? What is so interesting here? So I will say this theta is 45 degrees. And definitely interesting part is that it will be R max here. Regarding the 45 degrees, it is R max. Okay. And here you are supposed to remember the R max, U square by G. If you don't remember the formula, then you can't do this so easily. You have to go through the entire big formula and all. So elevation angle of the projectile at the highest point is, when it is at the highest point, then this H max, I hope you remember, I said that this H max will be R max by 4. R max by 4, that is equal to U square by 4G. R max by 4, U square by 4G. They're asking you the angle of elevation. So can I say this angle is angle of elevation? Let us say this is theta. This angle is angle of elevation. So tan theta is H max. Let's not write it as theta here. Let me write it as alpha. So angle of elevation alpha, tan alpha is equal to perpendicular by base H max by R max by 2. H max by R max by 2, where H max, because H max is attained at half of the range, no? Where H max itself is R max by 4. R max by 4. So numerator is 1 by 4 and denominator is 1 by 2. Numerator is 1 by 4 and denominator is 1 by 2. So what we can write, denominator will become numerator. So that will be 2 by 4 or 1 by 2. 2 by 4 or 1 by 2, which implies alpha will be equal to tan inverse 1 by 2. Alpha will be equal to tan inverse 1 by 2. So this option 4 is your result. Option 4 is your result. This is common way of doing it. And why? See, the method seems smaller. Here, even if I am saying it is a common way, you will not find any difficulty because method is smaller. The only issue is that you have to remember a lot of formula. But if you remember the cases, this common method is also very easy. But I also shared and this common method is only restricted when the examiner is asking the angle of elevation exactly at the top. But if they ask at any other random point, then this will not be applicable. This will not be a good method to solve the problem. Rather, our way of doing that problem is much better. Our way of doing this problem is, we always write tan alpha plus tan beta is equal to tan theta. All right, tan alpha plus tan beta is equal to tan theta. At H max, maximum height, bisymmetry and alpha and beta are going to be same. So twice tan alpha will be equal to tan 45 degrees, which is equal to 1, and hence alpha will be equal to 1 by, like, tan inverse 1 by 2. Tan alpha will be equal to 1 by 2. So alpha will be equal to tan inverse 1 by 2. I hope this logic is clear to you. All right. So common way is also there. It seems shorter only, but you have to remember a lot. And another restriction is that it is applicable only if you are talking about the topmost point, which is the PYQ also. But another time, if they ask the same thing in NEET, it's not necessary that they will ask you exactly at the top only. All right. They may ask you other things. So this method is always applicable. I hope that's clear to you. All right. Right, let me take you to another one now. So the angle of projection at which the horizontal range and maximum height of projectile are equal. The angle of projection at which the maximum range and maximum height and horizontal range are equal. Common way of doing that is, given they are saying H max will be equal to R. So H max value will be equal to u square sine square theta by 2g. R value is u square sine 2 theta by g. All right. So u square by g. See, I can see that u square cancelled, g got cancelled. 1 power of sine theta. So I can write it as sine square theta by 2. This sine 2 theta can be written as 2 sine theta cos theta. Another power, see, 1 power of sine and sine complete is cancelled. What you got here is sine theta by cos theta, sine theta by cos theta, which is also called as tan theta, that will be equal to 4. Okay, from here theta equals to tan inverse 4. From here theta equals to tan inverse 4. This is the general way of doing it. What the examiner is saying in the question. Our way of doing it is, we know tan theta will be equal to 4 H max by R. This time they are given that range is also equal to H max. This time they are given that horizontal range is also equal to H max. So numerator H max, denominator H max got cancelled. Theta is equal to tan inverse 4. I told you that this formula is always applicable. Tan theta is equal to 4 H max by R in any general condition. All right. So I think you are able to understand the essence and the beauty of these sessions which we are having, in which we are learning together. We are learning the fundamentals and all the NCERT things, understanding their modifications, and also we are trying to upgrade our skill, upgrade our problem solving skill, by which we will be able to solve a lot of crucial problems, but in much easier way. Are you interested in trying 2-3 more problems? Should I attach some more problems for your homework? Are you interested in that? Yes, sir? Chalo. You'll like it. You'll like doing it. I'll attach some 2-3 problems. Your target for today is attend all the sessions till evening. Another chemistry session will be started in a while for you. Then in the evening slot, physics and chemistry session you will be having. Make sure before you sleep tonight, you just revise everything and also attempt the few bits, whatever your we are telling you to do. So revise this thing in physics as well as attempt those. You will like attempting it. You will be able to get the answers in much easier way. All right. Notes will be attached in the description, and that's all from my side. Here we complete the oblique projectile motion. The story is never ended here. We have a lot more to learn and there is no limit, right? We will keep learning throughout our journey. Make sure you revise and you start working at your end now. It's time now that you again have to focus your entire energy and time towards your academic performance, and very soon we'll be meeting hopefully. And till then, you just keep working slowly, gradually on everyday basis. Right? Stay smiling, stay healthy. Bye bye. We'll meet tomorrow.